a very important thing, for your exam. Okay, so in this video we are gonna discuss class 10 physical science. Class 10 physical science. Okay. Class 10 physical science, English medium wbbse, most important questions. So watch this video with your utmost care and I can guarantee that you will be benefited. So without wasting any more time, let's start the video. So the first question says, why argon is placed before potassium in the periodic table? So the answer is argon's atomic weight is 39.94, which is greater than potassium's atomic weight 39.10. However, Mendeleev placed argon before potassium because elements in the periodic table were arranged according to their increasing atomic weight at that time. However, this arrangement led to some inconsistencies. Later, it was discovered that the atomic number, which represents the number of protons in an atom's nucleus, is the fundamental basis for the periodic table. Now, argon, whose atomic number is 18, comes before potassium, whose atomic number is 19, which aligns with the modern periodic table. But in the time of Mendeleev, the periodic table made by him was completely based on atomic weight. And as I mentioned, argon's atomic weight is more than potassium. Therefore, it used to be placed after potassium. Now, the next question, what are post-uranium elements? Post-uranium elements, also known as transuranic elements, are elements with atomic number greater than that of uranium, which has atomic number 92. Okay. So they are all radioactive and synthetic, meaning they are not found naturally in significant amounts and are produced in nuclear reactions. Example, neptunium, atomic number, let me write it for it. So example, post-uranium elements, also known as transuranium uranic elements. Okay, now, I have already read this type. Okay, they are all radioactive and synthetic, meaning they are not found naturally in significant amounts and are produced in nuclear reaction. They are produced in what? Nuclear reaction. Example, neptunium, whose atomic number is 93, or plutonium, whose atomic number is 94. Now, there are two characteristics of them, that is radioactivity. They have unstable nuclei that decay, emitting particles, and energy and syntheticity. They are all artificially synthesized in nuclear reactors or accelerators. Now, similarities and difference. The next question is similarities and differences in properties of hydrogen with alkali metal and halogens. Now, the similarities with hydrogen's similarity with alkali metals. Group 1 is like alkali metals, hydrogen has one valence electron. Okay, valency. isn't it? Now, and it can lose this electron to form a positive ion, just like all alkali metals. Now, in case of halogen, like halogens, hydrogen needs one electron to achieve a stable electron configuration and gains an electron to form a negative ion. Okay, just like halogen. Now, hydrogen's difference with alkali metals. Hydrogen is a gas at room temperature, while alkali metals are solid. Hydrogen is much less reactive than alkali metal. Now, halogen. Hydrogen is much less reactive than halogens. Hydrogen forms covalent bonds more readily than halogens. Okay. Now let's move to our next question. Arrangement of halogen in order of increasing properties. Atomic size. Increasing order, C. So it was said that you have to arrange fluorine, chlorine, bromine, iodine in increasing order. Okay. So according to their atomic size, ionization energy, and electronegativity. So according to atomic size, it will be fluorine, chlorine, bromine, iodine. Why? As we know that when going from left to right in a column, okay, the atomic size increases. No, I said it just wrong. The atomic size decreases. So that means just the opposite of that, when going from right to left, the atomic size will increase. Okay. So this is not applying here. Okay. The other thing, that is when going from top to bottom in periodic table, the atomic size increases. And so this is which is working here. See, in periodic table, the place of fluorine is just above chlorine, and the place of chlorine is just above bromine, and the bromine's place is just above iodine. So fluorine, chlorine, bromine, iodine, the size will increase. Now, in case of ionization energy, just the opposite happens. From top to bottom, ionization energy decreases. And so the order will be just the opposite. First there will be iodine, okay, and then bromine, and then chlorine, and then fluorine. In case of electronegativity, the same thing happens, that from top to bottom the electronegativity decreases. And so this is which is shown. So hope this video is liked by you. Now let me show you other questions. Now see, multiple choice question. Which of the following is not a transition metal? The options are ferrous, cobalt, calcium, and chromium. The answer is calcium. Explanation, you can see transition metals are characterized by having their outermost electron in the d orbital. But calcium is an alkaline earth metal which is in s block element and doesn't fit this criterion. Now, which of the following is not an alkali metal? Cesium, rubidium, potassium, and aluminium. Now aluminium is in the group 13. Okay, that is bromine group. Now elements with 1, 2, or 3 valence electron are typically metals. Metals tend to lose electron to form positive ions, and this alliance with having 1, 2, or 3 valence electron. Okay, explanation. The periodic table, next question, that emphasized the properties of element was developed by whom? Mendeleev, Dobereiner, Newland, or Lothar Meyer? Lothar Meyer, the answer. Now, the modern periodic law is based on Moseley's theory or his concept, whatever. Now, explanation. Henry Moseley's work with X-ray spectroscopy showed that the atomic number of protons is the fundamental basis for the periodic table of elements. Now, next question. The number of transition elements in the periodic table is 28. See the explanation. I know you might get confused when saying this, but see the explanation. There are 10 transition metals. Okay, we know that in 3D, 4D, and 5D, okay, there are 28 not but 10 transition metals. Okay, however, there is the 4F and 5F, okay, lanthanides and actinides series that are also considered as transition metals. So when taking this together, the number comes 28, and so this is why. Now match the items in column A with appropriate items in column B. Question A. Bad element. What is bad element? Hydrogen. Transition metal. Which one is transition? Copper. Alkaline earth metal. It is magnesium. Metallite. Antimony. So this is all for today, guys. Hope you enjoyed. Bye bye.